All right, here we are on April 25th, and I'm kind of hoping you've already worked on part one already. So I'm going to recap that, but that way you're ready for part two. You know what you don't want to do? Attempt part two when you haven't mastered part one yet. If you rush through part one, you're going to have trouble when you get to part two because this builds on that. And guess what? What we're doing next week will build on this. It just keeps building and building and building. So it's important that you master the material well. So this week's material, it would be a disaster if you put it all off till the weekend. It's just too much. You'd be trying to cram it into your brain and it wouldn't stay. You don't want that to happen. All right, so let's go ahead. Let's get these out of the way. And that one. Oh, Microsoft Word wants to act funny on me, huh? Okay. Now let's go take a look here. Oh, first thing I want to do, let's get over here to the main menu. And we'll give you all that feedback later. But over here in the learning modules, learning module 11, and getting over here, well, let's just take a look at the lesson. So here's the lecture notes. Now, hopefully you notice this one. Whenever you see the Z for next to a curve, that's the standard normal distribution where the center is 0, the spread is 1. And this document explains that. In fact, we could take a little peek at it. So if you say that, hey, I didn't see anything about the standard normal. Well, somehow you missed this document. So it's like what you're doing with the normal CDF with a population distribution. But here, the mean is always 0. Standard deviation is always 1. Because that's the standard normal. So take note of that. And then over here on activities, what's really important, I hope you've watched this movie because it steps you carefully through all of the steps you need to do. Now, when I say need to do, I mean so that when you finish the homework assignment, you've mastered the material. You've got the value out of doing the assignment. You didn't just do the work, you learn from it. And to do that, there's certain steps you need to do, and this movie lays that out for you. And of course, so you got the lecture notes there. So what I'm going to do is, first, let's take a look at these all-important documents. Now, here's a document that I'll have posted for you, and you've probably already seen it. But here, you had the movie showing you the steps. And of course, I'll be demonstrating the steps, but you also have it in this document. Because sometimes you just like to have the document and say, now what was that first step? Oh yeah. The recommendation is in all of these this week, you're told the shape of the population of quantitative data is normal. So you can get the shape. You're told the center, the population mean, what it's equal to. So you put it in the center on your sketch. And each of these tick marks is a standard deviation. So your population standard deviation is 8.7. And then you can add those, get those numbers, subtract to get these numbers. So you got those numbers all filled in. And of course, like you had on your exam 1, you can run the empirical rule through your head. So you know the interval that contains the middle 68%, the interval that contains the middle 95%, and the interval that pretty much has the whole thing, or 99.7%. So that's all well and good. Now, the idea is that, hey, you could find the area under this curve for any interval. You don't have to limit yourself to just these intervals here. But first, make this sketch. Now, in part 1, they're going to give you an interval, some lower bound and maybe some upper bound. Well, you want to locate those and then draw a vertical line there. So for example, let's suppose they want you to find this area under the curve, which represents the proportion of all the exam scores, because that's what this data is, that are greater than 95. So you need to find 95 on your number line. Say, well, it's somewhere between these two numbers. Well, if you want to know a little more precisely, remember z-scores? Well, take that 95, turn it into a z-score. Now, isn't it a lot easier to locate now? It's 2.4 standard deviations above the mean. So you locate it, draw a vertical line there, and then you shade in your area. But do you shade in the right or do you shade in the left? Well, they said greater than, so that's off to the right. So there you are. You drew your vertical line. You shaded in, and that's a picture of the area that you're going to find. Now, and one thing I want to emphasize is these sketches help you immensely in grasping and understanding the material. Our brains work so much better if we have a visual image to help us with grasping and understanding what's going on. And I've noticed a dramatic difference in my students. The ones who are lost and having a hard time, I notice they're not making sketches. And those who are getting it are doing really good sketches. Also, I find students who are really sloppy with their sketches, they don't do so well. So do a nice, good job on them. So you got the sketch, you got a visual of what you're finding. He says, and plus, the sketch helps you super clear. Well, I can see this number is my lower bound. Anything way bigger than this 100.1, so 1,000 would be far enough off to positive infinity. And of course, you were given the center and the spread. The 4 inputs you need for normal CDF. Oh, and then we have this probability inequality notation. Your sketch will help you with that. So you know this number is 95, so you put that in there. And you shade it in the right, so you put your X over on the right-hand side. So you got 95 here. And then you put in your inequality. Now, how do you know which way it goes? Well, my movie talks about this. Whoever's on the right side is bigger, because you know on the number line, bigger numbers off to the right. So it gets the big end of the inequality, and this is a smaller number, so it gets a small pinched end. I'll just put parentheses around that, a capital P in front, and that is the shorthand notation for that sentence. The proportion of all these data values that are greater than 95. We want to know what that's equal to. Now, in your work and on an exam too, make darn sure you do this, always show the function you're using along with the inputs. So, we can see the lower bound. Here's your template. Got your lower bound. I did 1e99. You don't have to do that. That's scientific notation for 1 times 10 raised to the 99th power. But if you put your numbers in, as long as you got you're way off to the right, like 1,000, you could just use 1,000 in this particular case. And of course, you're given the center and the spread. You punch that in on your calculator, and let's do that just for practice. You press second, you press vars, 2 for normal CDF. And yes, you do have to put them in this order, of course. You change the order, don't expect to get the right answer. So you got 95, comma, that's above the 7. In fact, I'm just going to put in 1,000 because I told you it's going to work just fine. So let me show it to you. And then put in your center, your population mean is 74, comma. Standard deviation for your population is 8.7, right parenthesis. And even before you hit the answer, because you did the sketch, you can see it's going to be a small probability. So you have an approximate idea of what your answer is when you make a sketch. So, yep, that's pretty small, and I was expecting small. That looks reasonable to me. So you can write as a decimal. If you want to write as a percentage, well, you got to multiply this by 100 so that decimal point gets moved across. So make sure you can correctly rewrite in as a percentage and get your decimal point in the correct place. Because if you don't, your answer is very wrong. Now, here's what I encourage you to do in part 1. is take this answer and put it in your sketch. And what I do is whenever I'm talking about an area under the curve, I write those numbers above and point down to the area. If it's a number that's on the number line, I write it below and point up to where it is. The reason I do that is the thing that you have to work with and grasp and understand, and it takes practice, and that's what the homework exercises are for, to remember which numbers are points on the number line and which numbers are areas under the curve. You have to be super clear on that before you do part 2 this week. If you're not, you're going to be confused. So how you prepare for it is in part 1, when you got your sketch really helps you with this. That's another reason to do the sketch. Oh yeah, you see, normal CDF always gives me an area under the curve. An area under the curve is a proportion or a probability, and those are percentages. Got that? And when they told me 95, that was a data value. That's what's represented by the numbers on the number line. So being super clear about that. And it's also not a bad idea to review this. I was given the interval. When you're given the interval, you use normal CDF, and it gives you the area under the curve. It's worth running that through your head on every exercise you do. Why? It prepares you for part 2. What's part 2? You go backwards. In other words, they'll give you the area, and you have to find the interval. Just the opposite of what we did here. Well, they're going to give you an area under the curve, so you better recognize, oh, they didn't give me an interval. They gave me a proportion of the population. They want me to find this interval. In this case, you know the upper bound is positive infinity. You'll want to find the lower bound. But that takes a different function on your calculator. But we'll get to that when we get to part 2. Now, you want to interpret this area under the curve in 2 ways. As a probability, which is the probability of one randomly selected from this population being greater than 95 is 0.79%. Now, is that probability small enough to be considered unusual? Yeah, because if you're 5% or less, you're a small probability and you're considered unusual. Now, this is the proportion of the population that is larger than 95. So 0.79% of all these exam scores are more than 95 points. All right, and I already, I guess, did number 8 earlier when we're focusing on this number is the area under the curve, 95 is a point on the number line. But those are the 8 steps. You do those 8 steps on every exercise in part 1, you will be prepared for part 2 and you won't be lost and confused. Because you'll be super clear on, like when you're given the 95, oh, that's a point on the number line. When you had your answer of 0.79%, you say, oh, that's an area under the curve. And you're super clear about it. But it takes practice to get there. So those are the steps that we're going to do as we do some practice exercise. So let's move on to those. All right, so let's suppose here we are. We got a population, and guess what? Their exam scores. And here you're given the shape, center, and spread. Now, oh, wait a minute. This is the one we just looked at. So you can see that I would have just gone through that same process. But I'm going to do it because I was just pointing and showing it. That's not the same. So what we're going to do is go. Now you can see that I've already got the numbers in. So you would be doing that yourself. You would, one way to do it is take 74, subtract 1, and then parentheses put your standard deviation. I mean, this isn't the only way to do it, but it's a fast way to do it. And it gets you to review the empirical rule. So you can see, yep, these are the lower bound, upper bound that contain the middle 68%. Then just press second enter and edit this to a subtract 2. Second enters, change that subtract to plus. That's the interval that contains the middle, 95%. That's the really important one. These are the typical usual data values that are reasonably close or within 2 standard deviations. Beyond that are the unusually large 2.5%, and below this is the unusually small 2.5%. So let's finish the job. Second vars, subtract 3, and second vars, and we'll change that to a plus. And there's our final interval that pretty much contains the whole population. Now, so let me step through the process I want you to do on every one of these so you master the material. Now, this is why you pay the big bucks for in this class, because this is something you wouldn't have thought of probably on your own. And if you did, you wouldn't realize how important it is. I'm telling you, this has made a huge difference in the students who have done it versus those who haven't, that follow this advice. Now, so I need to get up here. Let me get my annotation tool all booted up. Yeah, get that? So you say, now I need to find out where 95 was. You say, I could eyeball it, but what I recommend doing is the z-score. Whoops. Now that's weird. This was working just fine. Oh, there we go. I was practicing this earlier and it was working really well. Now that I'm going at this, so let me try it. I don't want to have to use my mouse, but I might have to. Because I write bad enough with the tablet, but if I'm doing the mouse, it's pretty hideous. But so be it. So you've got your x value, which is the 95. Yikes. And we're going to subtract the center, which is the 74, and divide that by the standard deviation, which is the 88.7. Not 80, 8.7. So you go over to your calculator here. Oh, I better turn that off. And be sure to use parentheses like you did on your exam 1. 95 minus 74. Because your answer will be very wrong if you don't. And so that's how I knew, yep, right here, 2.4. So here we go. All right. I'm going to try this one more time. This should be swell if it works. So we go right there. Now it's being weird. Back to the mouse. So, like I said, 2.4, that's about a half. So it's just somewhere right around there. And then it's off to the right, so you shade it in like that. And you say, all right, so this point right here is the 95. And if I shaded in the left side, I put X over on the left. But I shaded in the right, so I put X over here on the right. Now, you compare the two. Whoever's farther to the right gets the big end of the inequality. Put your parentheses around it, and a capital P in front. Maybe better looking P in that. But that's your shorthand notation for the proportion of all exam scores that are greater than 95 points. Happens to also be the notation for the probability of one randomly selected exam score being greater than 95 points. Now, because my pad isn't cooperating, I'm going to clear this and scroll down so you can see the better work. So here's the notation, the function. We actually already punched this one in, but then stating it as the probability and as a proportion. But this is as a probability, and then down here is what it looks like as a proportion. Now, let's look at another one. We want to find the probability of one randomly selected exam score being less than 59 points. Well, where the heck is 59 points? Hey, we got the same center, same spread. I could be super lazy here. I could press second enter and just change that 95 to the value they gave me here, 59. So 59 is where? 1.72, that's right about there. So we draw a line right there, and it's less than, so we shade in the left. So I'll go ahead and I'm going to draw that in. So like we said, y is about almost 1 3/4. Okay. Now can anybody hear me? Sorry about that. I had my headphones plugged in, but I just noticed they weren't plugged in all the way. And if these aren't plugged in, well, by golly, nobody can, they turn off by themselves. But if I keep them plugged into the USB, we're okay. So I wasn't careful. I'll watch that next time. Make sure I do have, and thank you for mentioning that. So we'll go ahead. Now, I'll also notice, let's see here, that that was also, anytime you find the area to the left of a point, that tells you the percentage of the population that's below it. And that is its percentile rank. Because remember what percentiles are. We covered them earlier, but this is a new way to visualize them for a normal distribution. Take any point on here, draw a line, shade in the area to the left of it, and that's the proportion of the population that's below it. And then that means that's its percentile rank. That's the percentile it's at. So when we found the area to the left of 59, and the area to the left was 4.23%, it was at the 4.23 percentile, or third percent, 4.22nd, 23rd percentile. And depending on how you want to round, if you want to round off to 4, you would say it was at the 4th percentile. It depends how much accuracy you want. Now, these are common mistakes we all make when we're first learning this stuff. So just be aware of this, and if you do make the mistakes, just learn from them. So for example, like when I was doing this one up here, I used 0. But let's suppose I did this. I pressed second bars 2, and I did the -1. Then to get the E, you press the second key, the comma key, 9, and a comma. Now, where you got to be careful, see that negative? You cannot use the subtract key. You have to use this key for negative numbers. And that E, how you get it is you press the second key and the comma key. You say, you mean I can't just press the alpha key and this key and get the E in there? No, that's not the same. No, that's not scientific notation. So this is -1 times 10 raised to the 99th power. Imagine a -1 followed by 99 zeros. Oh, well, let me finish the job here. The upper bound was 59, comma. The center was 74, comma. And the spread was 8.7. Do we got the same answer? We sure do. So once again, you just go way off to the left, you'll get the same answer. But here's the pitfalls here. Now let's suppose I'm going to press second enter so I get the same thing again. What if I accidentally forgot to put that negative in there? Well, now your lower bound is bigger than your upper bound, way bigger. What does your calculator do if you give it an interval that cannot exist? Because you know your lower bound can't be bigger than your upper bound. Well, it shouldn't be. But if you do something like that, here's what your calculator does. That'd be great if it would give you feedback and tell you you put your interval in wrong, but it doesn't. It does something far more devious. It gives you a negative probability. Now, from what you know about probabilities, can they be negative? No, that's impossible. So that's its way of telling you. He says, well, if you give me an impossible interval, I'll give you an impossible probability. How do you like that? Well, I think it's trying to humiliate you, because if you wrote that answer down, why people will wonder why you wrote down a negative probability and why you didn't notice that that's impossible. You know, the area under the curve can't be a negative value. So if you see that, look at your lower bound, upper bound, because that's where your mistake lies. So watch that. You know, when you're doing this, that's bound to happen, probably just because you press the wrong key or something. So, but the important thing is that you notice your answer wasn't possible. And this is just to give you a heads up on how to find what the mistake was. Okay. Now, this would be a really tragic mistake. They're saying, boy, I don't know, doing those sketches, those take too much time. I think I'm gonna save time and not do them. Well, actually, what's going to happen is you're going to spend far more time in frustration because you won't be getting the material and you'll keep going over it, and you're not getting it, going over it, not getting it. Whereas if you had made the sketch, you'd be getting it, and you're saving time that way, and you're saving frustration. The sketch is one of the most valuable tools you can use to learn this material. Okay. And if you say that, well, I don't see why that would help. Well, come on. You're not qualified to make that call. All right. You haven't observed hundreds of students looking to ones who did and haven't done that. So just take my word for it. If you want to be one of the lucky, happy students, make the sketches and do a good job on them. Really consciously think about what you're doing when you make them. Now, watch out for this. Thinking that once you got the answer on your calculator, you're done. No, really, because you notice the 8 steps after we got that answer, we put it on our sketch, we interpret it as a probability and as a proportion, we reflected on which number is an area under the curve, which is a point on the number line, where we're running a lot of important concepts through our head after we got the answer. So, but that's why you've got that document with those 8 steps, and the movie stepped you through them so that you're aware, this is what I need to do so I will learn the material actually in the shortest amount of time. It looks like it'd be the longest with all the steps, but if you measure how long it takes you to master the material, those steps are going to get you there the fastest and with the least amount of frustration. Now, so with that being the case, now we're going to go backwards, where they're going to give us the area under the curve, and we're going to find the interval. Now, here's the steps for those. I'll make this a little bit smaller. And this document lets you know. Now, the steps are quite different when you're given an area under the curve instead of an interval. Now, when you're given an area under the curve, it can be in only one of 3 ways. Maybe they'll just give you the area in the left tail. Or maybe they'll just give you the area in the right tail. Or the only other way, like you see here, they give you an area where it's perfectly centered in the middle. So they would call this the middle 90%. Now, think of this. Think of the empirical rule. You know about the middle 68%, the middle 95%, the middle 99.7%. Well, what if you want to find a different middle percent? Well, that's what we're going to do here. You can find any middle percent you want. The important thing is you got to make what we call a rough sketch. When I say rough, I mean we don't need to find the numbers on the tick marks. In fact, we don't even need the tick marks because we're really eyeballing it. So if they gave me an area in the left tail and they said it was 5% in the left tail, I go, I don't know, it might be somewhere around here. I'll just guess. I'll shade in that left tail and point to that area and say that's 0.05. Or if they gave me the area in the right tail, maybe they said it was 5%. I would just make a wild guess about where it is, shade in that right tail, point to that area in the right tail and say it's 0.05. But this one's a little trickier. When you're given the middle percentage, this will step you through it. All right, so you don't know quite where to put these lines. You know it's more than 68% and less than 95, so you know just somewhere between 1 and 2 standard deviations. But you don't even need to worry about that. Just make a wild guess, just so it sort of looks centered, and then clearly show in your sketch that this, and then shade in that center area and say it's 90%. Now what you need to do is, what's in the tails here? Well, go to your calculator. What's the entire area under the curve? Well, 100% or 1. Well, We'll take that entire area 1 and subtract whatever the middle percentage is that they're asking for. Well, that's 0.9. So I'll subtract 0.9 from 1. So I know these two tails add up to 0.1, which is 10%. Well, take that 0.1 and divide it by 2. And that tells you what's in each tail. Oh, so that's what 5% looks like. So doing it this way makes sure you get the decimal point in the correct place. So this area here to the left is 5%. This to the right is. So you actually put those into your sketch. It's very important because you need to know the area that's in each of these regions. So that's the first really important step. And plus you notice, hey, look, I'm working with the areas under the curve. Boy, this is just the opposite of what I was doing in part 1. But when they said middle 90% of the population, because of part 1 and you're interpreting your answers from normal CD, if you recognize, hey, the middle 90% of the population, that's an area under the curve. So you start sketching it. Now, you want to find this point on the number line because that would be the lower bound for this interval, and here would be the upper bound on the number line. Well, inverse norm will find that for you, but it needs to know the percentile rank for the data value for which you're asking. So what's the percentile rank for the lower bound? Well, what's the area to the left? 5%. So this is at the 5th percentile. Now, what's the percentile rank for our upper bound? Well, what's the area to the left? Well, I got 90% plus this 5%, so that adds up to 95%. So the upper bound's the 95th percentile. But you see how my sketch makes sure I know what the area to the left is for my lower bound, what the area to the left is for my upper bound. Because that's the inputs inverse norm is going to need. So this lower bound is inverse norm, give it this area to the left, and then the center and spread for your population. Of course, those are given to you. You enter that into your calculator, and it'll tell you the lower bound for this interval. So remember, inverse norm gives you a data value, a point on the number line. What does normal CDF give you? An area under the curve. So focus on that, and when you get an answer, reinforce yourself and put it in your sketch so you're super clear which numbers are points on the number line or data values and which numbers are areas under the curve or probabilities or proportions of the population. And here's your upper bound with its area to the left and center and spread. But that will be your lower bound, upper bound for your interval. Now, step 5. After you get your answer, even though you're tempted, don't stop there. You're not done yet. Because your big hurdle is you got to get super clear what that answer means. Because if you're not, sometimes students who aren't covering this well, we're going to get their numbers confused. They get inverse norm and they start acting like it's a percentage or a proportion. Well, it's not. It's a data value. It could be exam scores, it could be ounces or tons or whatever it is we're measuring. But it's the units of measurement. It's a data value, point on the number line. So to reinforce that, you do this. Write out your answer using the probability inequality notation. And you got your sketch to help you with that. So for example, let's suppose the lower bound was 62, upper bound was 88. So you'd say, all right, this is 62, this is 88, X is in between, put in your inequalities, put the parentheses around it, and a capital P in front. And it'll look just like this. And you'll say, look, they gave me the area, and I found the interval using inverse norm. And of course, if that's true, then I should be able to put this interval into normal CDF, and it should give me this area. So you want to run that through your head. That's right. If I'm given an interval, then you use normal CDF to get the area. If I'm given an area, I use inverse norm to get the interval. And you know what will help sink that into your head? This image right here. This is probably worth printing out and pinning up somewhere, because you're going to be given one of two things. Either you're given an interval like you were in part 1, or you're going to be given an area under the curve like you were in part 2. Well, if I'm given the interval, what do? I'll follow the arrow. Oh, I use normal CDF, and it gives me the area under the curve. But what if I was given an area under the curve? What do? Follow the arrow. I use inverse norm to get the interval. But this shows that relationship between them. And it reinforces, when do I use inverse norm? When do I use normal CDF? And my answer to you is, well, what did they give you? An interval or an area under the curve? And once you know that, you know what to use. Just keep reviewing this till you get it. Daily practice. So review it each day. It's easier and easier to remember. And the unfortunate people who put the work off to the weekend, they don't have that luxury. They're trying to cram this into their head, and it doesn't stick very well when you do that. But you've got getting a nice early start, so you keep running it through your head. All right? So you do that, and I'm telling you, you will master the material in the shortest amount of time. You say, I didn't say you'll get the homework done the fastest, but that doesn't really count for much if you didn't learn anything, and you have to keep going back over it, trying to learn it. Well, if you do it right the first time, you'll save yourself that grief. All right, so let's try some out. Now, what I'm going to say is, we don't know what's coming next. Oh, isn't it going to be inverse norm? Maybe it is. Maybe it isn't. I want you to think about this. What did they give us? And then I'll know what to use. So let's read carefully. So we got the shape, center, and spread. As always, they're saying find the percentile rank for an exam score of 65. Well, I'm hoping you remember what a percentile rank is, because we were just talking about it a little while ago. The percentile rank tells you the proportion of the population that's below a data value. So they're giving me a data value, and they want me to find the area to the left. So 65, is that an area under the curve or a point on the number line? Well, it's a data value, so hopefully you know that is a point on the number line. And we can see that, well, 65, that's just to the left here a little bit. But of course, we can do the z-score. In fact, let me just go to the calculator. So we'll take our 65. We'll subtract the mean of 74 and divide by the spread 8.7. So there's your little z-score calculation. That makes sense. We know it's off to the left, so it's just a little more than one standard deviation below. And so let me get my little annotation tool. And so it's off to the left here, just off a little smidgen. And the percentile rank, that's the proportion of the population that's below to the left. So we'll shade that in. So does it look like it's going to be a probability less than 5%? No, it definitely looks bigger than that. Now, so right here, just to the left there, we have our 65. And all our data values, X, are over here on the left-hand side. So 65 is bigger, so it gets the big end. So here's the notation. This will tells me the proportion of the population that's less than 65, which tells me the percentile rank. And so we're going to use normal CDF. So we do equals, and we would write normal CDF here if it would cooperate. And then we could go ahead and calculate that. So let's go ahead and do this. So we're going to press second vars 2. Now, why are we using normal CDF? Because we were given an interval. So you use normal CDF to find the area under the curve. All right. Now, what should we use off to the left? Well, you could do the -1 E99 if you want, or anything far enough to the left, like 0. 65 is our upper bound, comma. Our center is the 74, comma, and the spread is 8.7. Hit enter. All right, so there's our answer. About 15.05%. Get my annotation tool up. So I'll say 15. Now, if you want to round off, you could say 15%. That's a percentile, but maybe you want to be a little more accurate, so you'll say 15.05%. So it's about at the 15th percentile, because 15% of this population is below 65. So they got a 65 and they're feeling a little depressed, but they can console themselves. Well, at least I did better than the 15% who did even worse than me. So at least I'm not at the very bottom. So you see, percentile ranks cheer you up. They're telling you your exam score. They're telling you what makes you feel good, the percentage of people who did worse than you. The last thing you want to hear is this percentage to the right who did better than you. Okay, now let's clear this off. And you can see it in a much neater, tidier format. And so 15% probability that one randomly selected exam score from this population will be less than 65 points. And that's not unusual because that's way bigger than 5%. And you could say 15% of all these exam scores are going to be less than 65 points. All right, now let's see what happens with this next one. And what we're going to do, we're going to ask ourselves, what did they give me? Is it like the last problem where they gave me an interval, so I use normal CDF? Or are they going to give me an area on the curve and I'll have to use inverse norm? Well, let's wait and see. So here we are. And same population, but they want us to find the exam score that's at the 15th percentile. Hey, they're giving me the percentile. Boy, you really need to know what percentiles are, don't you? So what I got to do is try and make sense of this with a very rough sketch. Remember, that was the instructions. Oh, so once again, 15th percentile. So if I'm at the center, I'm at the 50th percentile. But if I want this area to the left to shrink down to 15%, it's somewhere off to the left. But I have been given an area under the curve. So that's first you got to know what a percentile is. And once you know that, then you realize they gave you an area under the curve. So that's why we're going to use inverse norm. But first, we got to make our rough sketch. So we're going to do that. So you're saying, look, I don't know where this is. I'm just eyeballing it. So you just draw a straight line here, and you're not sure. You're just kind of guessing. And it says, but I do know it's going to be the area to the left. So let me shade that in. I'm doing straight lines. Looks a little better when I do that. All right, so there's a picture. Oh, and then of course, I need to do this. Clearly mark what it is that area is. Well, it's 15%. So I'll say that is the 0.15. We'll make that point really noticeable. Okay, that's a little overkill, but 0.15. Once again, I'm drawing with my mouse. That's why it looks so bad. Now, we've got that. Now, you realize, well, who could we use? Who's going to help us find that point on the number line? And you realize, well, that's a job for inverse norm. Try to write inverse norm. Now, it has 3 inputs. You don't need to memorize this. It'd be on your formula sheet on exam 2. But it'd say the area to the left. Well, that's where my sketch comes in here of all the data values. I see the area to the left is 0.15. Let's see if I can make this look a little better than what I wrote on my sketch. 0.15, comma, and then it just needs to know the center and spread. So the center is 74, and the spread is 8.7. So it just needs 3 inputs. Area to the left, center, and spread. So let's go ahead and punch that in. So I'm going to hit clear, and we'll press second, vars, but this is choice 3 for inverse norm. Now you got to enter that area as a decimal. So 0.15, comma, then 74, comma, then 8.7. Right parenthesis. Hit enter. So 64.95, is that about 65? Yeah, you could round off to 65 if you wanted. So let's go over here. But if you want to be more accurate, you can do that too. Say, oh, no, it's not 60, that's 64.98. Well, that'd be all right. But I'm going to round off to 65. So what I'm going to do is, I want to put this in. I don't want to stop right here, because this is where we're going to reinforce what inverse norm does, what normal CDF does. Because if we don't, we're not going to really master this material when we finish the homework. So this point, right on this point on the number line right there, is the 65. And the area is to the left, so put X over to the left. 65 is to the right, so it gets the big end. Put the parentheses around it, and the capital P. So this reinforces the inverse norm. That number is going to be inside the parentheses because it's part of the interval. Well, it's the upper bound for the interval. And what is this equal to? The 0.15. So you say, that's right, the 0.15, that was the area under the curve. 65 was a point on the number line. Now look what just happened here. They gave me the area, and I used inverse norm to find this interval. Now, wouldn't it also be true that I could take this interval, put it into normal CDF to get this? Well, isn't that what we just did? Because remember, when we found for the data value 65, the area to the left was 15%. So in essence, we're just doing the opposite here. But here's what you can do. Let me turn off my annotation tool. Let's suppose you hadn't done a similar problem right beforehand. You're saying, all right, if this is true, I can give this interval into normal CDF, and I'm going to actually do it. I'm going to press second, vars 2. Now the lower bound for the interval is way off to the left, like 0, comma. Now the upper bound is 65, but I'm going to punch in more accuracy. It's right above you there. So it's easy to just look at it and punch in the whole thing. .9830296, just to reduce your round off error, comma. And then, of course, what were the last two numbers of normal CDF? The center and the spread. Now, before you hit enter, you say to yourself, well, this should be equal to the 15%. Or at least it should be really close because of all the accuracy I did here. Is that really, really close to 15%? It is. So by doing that, I did this little thing with normal CDF just so I could reinforce this little thing here. Say, that's right. Because if I took the interval, I was able to use normal CDF to get the area under the curve. I could take the area under the curve, use inverse norm to get the interval, and do it again and again and again and again, and go on forever and ever and ever, going back and forth, back and forth. All right? So that's the recommendation of the steps to do on every one of these. One of the, and before, when you do the homework in my stat lab, do your work on scratch paper. Actually do all the work I'm showing here and then enter your answer in. Try to avoid the trap of not doing any of this. I just thinking, oh, I'll just punch it in my calculator, get the answer, and enter it in. You're not going to learn the material as well that way. You don't believe me, you can learn it the hard way, but if you want to get the benefit of paying the big bucks for this class and get the pointers that'll make a big difference, you're going to follow all those suggestions that I gave you in these documents. Now, let's see here. Let me clear this off. And here you can see it in much neater and tidier. All the things that I said. All right, now let's go over here. Now, let's find the cutoff score for the top 15% of all the exam scores. So let's suppose you had this really nice teacher. And it says, okay, students, the students who get the top 15% of scores are going to get a nice piece of chocolate. And you're going, oh, how high of a score am I going to need to get in order to be one of those lucky people? Well, let's suppose it's known the population mean and the population standard deviation, and we know the distribution's normal. Well, then we could find this cutoff score for the top 15%. So you're looking at exam scores, the top ones are off to the right. So where is that 15%? That's 15% of the population, so we know it's an area under the curve. So it can only be in the left tail, the right tail, or centered in the middle. Well, these are the top ones, so that's all stuffed here in the top, 15% in the right there. Okay, so now you know. And what you do is you make your rough sketch. So let's do that. Say, look, I know in the center is 50% to the right, so I got to shrink that down to 15 by moving to the right. How far? You go, I don't know. Of course you don't. You're just going to eyeball it. So you just draw in a line there. Oh, I should be doing the straight lines. Those look better than my hand-drawn ones. And let's just shade in to the right. So those are your top 15% of the exam scores. And clearly label, so that right there, that area is 15%. Oh, funny looking decimal, 1, 5. All right, and I should put an X here so you know it's the population distribution. So we want to find that lower bound. We know the upper bound is positive infinity, but we need to find that. But what area am I going to give to inverse norm? So think about that while I carefully write inverse norm. Am I going to give it 15% or am I going to give it a different number? So it's got to be the area to the left. Oh, that's this unshaded region here. How am I going to find that? Take the entire area under the curve, which is 1, and subtract what's in this right tail, 0.15. And of course, you can punch that into your calculator, and you'll get 0.85. So it's at the 85th percentile. So that's what you'll put in here, 0.85. And then you just need the center and spread, which are staring us in the face right there. So you do know you have to be at the 85th percentile to be at that cutoff point. We want to know, well, what's that exam score? That's what I want to know. What do I have to get on that exam to make it into this prestigious group of the top 15%? And so that's what our calculator will tell us. So we press second, vars 3, and 0.85, comma, 74, comma, and 8.7. Now that's an exam score. So you need to get an 83 on this exam. And if you do, you just made it into the top 15%. So if you get an 83 or higher, you're in this group. And you get a nice piece of chocolate. Okay. So, but we're not going to stop here, are we? No, let's reinforce the important things we got to do so that we're going to actually learn this. So I know this point on the number line right there is the, I should write this answer that we got there, 83. If you want to say 83.02, you can. In fact, I will, 83.02. Now our general rule is go out at least 2 decimal places. I know I didn't on that previous one, but I wanted you to see how it matched up with that previous problem. Now I shaded into the right, so put your X over to the right. So X gets the big N because it's farther to the right, making it bigger. And put the capital P in front. And there's your notation. But also let's say what it's equal to. What is the area that goes with this interval here? It's not the 85%, it's the 15%. Because our interval is going from this point off to the right. So we got to use that area. And then you say to yourself, well, look, they gave me this area to the right. I use inverse norm and my sketch to figure out this was the interval to go with it. Now, I knew the upper bound was positive infinity. I just had to find the lower bound. And I found it was 83.02. Now, let's go ahead. Oh, yes, and let's do this. Well, if this is true, I should be able to give this interval to normal CDF, and it should give me this answer. Why? I think because we're just learning this, it wouldn't hurt us at all to reinforce this. I'm going to press second, vars 2. And let's see, the lower bound is this 83. And I'm just going to look right above and enter that in with all its accuracy. 0169, 704. Then a comma, and then anything way off to the right. Well, 1,000 will work. You don't have to do the positive 1E99, comma, and then our center and spread. Right parenthesis. And before I hit enter, I say, what's this going to be equal to? Well, it should be really close to my 15%. And it is. So once again, you're reinforced. Normal CDF takes the interval and gives me an area under the curve. Inverse norm needs to take the area, of course, is the area to the left, and it gives me the point on the number line. So if you run that through your head on every one of these, don't you believe you're going to get it down pretty well by the time you're done? You will. You don't do that, you won't get it down as well. So don't think it's a silly waste of time following up a normal CDF. Because the students who don't do that, when they finish the homework, they ask this question: how do I know when to use inverse norm or normal CDF? Well, what do we know for sure? They didn't follow this advice, did they? Because if they had done this, they wouldn't be asking that question. So let's go ahead and clear this drawing. Got one more. This will be the last one. So if you got any questions, you better think about asking them pretty soon. Now, what's different here? This is a middle percentage. Hey, we covered all the bases. We did it where the area was given in the left tail. They gave us the area in the right tail. The only thing left, centered in the middle. So we got it all covered after this one. Now, they want us to find the interval that contains the middle 80% of the exam scores. Now, you need to recognize that's an area under the curve because that's a proportion of the population. In other words, they gave me an area under the curve. I'm going to have to use inverse norm to get the interval that they're asking for because they want me to find the interval. So we're going to make ourselves a rough sketch. So I'm going to do that. Now let's see. If I go one standard deviation, that's 68%. Two, it's 95%. So it's somewhere in here. I don't know exactly. So I'm just going to eyeball it. And I'm eyeballing, trying to make it sort of look like it looks somewhat centered. But it's a rough sketch, so don't sweat if it doesn't look perfectly centered to you. And then we're just going to shade in the center area. There you go. And then, of course, we will clearly label it. So I'll emphasize this is the middle 80%. So even if I didn't do a good job of making it look like it was centered in the middle, this makes up for everything. Middle 80%. Oh, let me write as a decimal because that's what you're going to have to work with on your calculator. So what do you got to do? You better find out what's in each of these tails. And we went over this once. What we're going to go over it again. Take the entire area under the curve, which is 1. Subtract whatever the middle percentage is they're asking you, but that they gave you, 0.8. So that's what the two tails add up to. Because of the perfect symmetry, half here, half there. So what's half of this? Well, let the calculator tell you. 0.1 or 10%. Now let's put that into our sketch. So we're going to have an arrow there and have an arrow here. And so this is 0.1. So my lower bound is at the 10th percentile, 0.1. And now this area in the right tail is 10%. So we're going to have to use inverse norm to find this lower bound. And we're going to have to use it again to find the upper bound. Now you might be wondering, how come I have to do it twice this time? Because with the previous ones, they went off to infinity. So we knew what one of the ends were. When you give an area in the left tail, I know the lower bound's negative infinity. I only have to find the upper bound. If it's in the right tail, the upper bound's positive infinity. I only need to find the lower bound. But here, I got to find both of them. Well, that's okay. Inverse norm makes it pretty easy. So I've got inverse norm here. Now, I made my sketch so I would know what the area to the left is. So what's the area to the left here? My sketch tells me 10%. So it's 0.10. And I'll do a comma, 74, comma, 8.7. Not a very good looking 8. Now, how about this one here? That's going to be inverse norm. While I'm writing this, why don't you think about what the area to the left is? So, area to the left, I got 80% here, but that's not all the area to the left, is it? I've also got this. You might say, oh, you're going to got to do all the area to the left? Well, that's what a percentile is. That's what the area to, all the area to the left. So 80% plus 10% is 90%. So this is the 90th percentile. 0.90. And then, of course, you'll do the center and the spread. It's 8.7. That's a funny looking decimal. So that's what we're going to punch in. So what we're going to do is hit clear, second vars 3. And let's see, we're going to do the 0.10 for 10%, and then 74 for center, and 8.7 for spread, right parenthesis, enter. Now you notice my other inverse norm has the same center and spread. If you want to, you don't need to do this, but it's a time saver. You could press second enter, gives you the same thing you just entered in. What's the only thing I need to change? Change that 10% to 90%. And oops, I didn't, guess I didn't enter that in like I thought I had. Let's try that again. Press 9. There we go. That looks better. All right. So the lower bound is 62.85 and the upper bound is 85.15. So I'll go ahead and write that in. Let me use a little different color ink so it'll show up a little better. So this point right here was the 62.85. And our upper bound's 85.15. And where's our x? Well, it's in between here. So put it in between. Now, just compare these two. Who's bigger? Whoever's farther to the right. Now just compare these two. Who's bigger? Whoever's farther to the right. Put your parentheses around there. A capital P in front. There's the notation. And what is this equal to? The area that they gave us, the 80%. And by writing it out in this notation, you're reinforcing that the inverse norm gave you points on the number line, the lower bound, the upper bound, and that you were given this area under the curve. I'll try and make that look a little more like an 8. Doesn't look too good. There we go. Now, if this is true, shouldn't I be able to put this lower bound, upper bound in a normal CDF and it should give me this? Well, sure. This is our last one. Let's set a good example. Turn that off. And so I'm going to press. Now, I almost pressed the clear key and I stopped myself because I kind of want to see these numbers, don't I? So I'm going to press second, vars 3. Now let's put in that big old lower bound, 62.8505. 0137. Just because we don't want round off error, do we? Or very little. Now let's put in that upper bound. 5.1494, 9863, comma. Now just put in your center, 74, comma, put in your spread, 8.7, right parenthesis, and before you hit enter, what's it going to equal? It's going to be really close to 80%. Oh, let me see what I did here. I entered something in wrong. I got that. Oh, you see what I did? Boy, that's embarrassing. I put inverse norm up there. I meant to do normal CDF. Let's see if I can get away with this. I'm going to press second vars 2. Oh, I wasn't sure if that would work or not. So I replaced inverse norm with the correct function. Now, that was nice. Instead of giving me an impossible answer like I deserved because I entered the wrong function, it says you couldn't possibly have done the right thing. Inverse norm only has 3 inputs and you gave it 4. And so that's why it gave me the error message. But the inputs are all correct now. I got the correct function. Now when I hit enter, I should get 80% or really close. And it is really close. All right. So the built-in things. You enter in the wrong function, you should expect to have an error message because it has a different number of entries. If you run normal CDF and you get a negative probability, look at your lower bound, upper bound. You might have them reversed. That's usually what happens. But the problem is in your lower bound, upper bound you enter. All right? So that's what you'll be working on. Be sure and spend some time on it each day, running through your head this little thing. Keep it straight. You know, which numbers are areas under the curve, which are points on the number line. Oh, let me clear that drawing so it looks a little clearer. But that's a nice way to keep it organized in your head. All right? So that's our lesson for this week. Now, next, I also should mention this. This week and next week are often referred to as the hurdle for this class, because you'll notice that this work this week takes more time. Well, sure, it takes more time. Look at all those steps I gave. But that's what it takes in order for it to sink in. Now, it'll take you even longer if you don't do those steps. Now, and then next week is a more challenging material too. But once you master that, you'll be set for the second half of the term because you'll have the whole foundation, and then everything will make sense after you master the material for next week. And before you can master material next week, you got to master this week's material. All right. So we'll be seeing you next week. And of course, you got your little calendar so you know when that is. In fact, probably wouldn't be a bad idea for me to look at that right now. So our next session will be on May 2nd. So next Wednesday, same time, same place. Now we'll see you then.